Hello everyone, welcome to Miss Lee's class. In this section, we're going to learn how to use sine and cosine ratio to find side lengths. So in the last section, we learned how to use tangent ratio. And in this section, we're going to learn how to use sine and cosine ratio. Okay, before we start, we learned regular sine and inverse sine, regular tangent and inverse tangent last class. So we're going to continue using both regular sine and cosine and inverse sine and cosine. So when you want to find, when the angle measures are given, and if you want to find the ratio, you use regular sine and cosine. And when you want to find the angles, you use inverse sine and cosine. Okay, so here, determine sine 10 degree. So the angle is given. So when angle is given, you use regular sine. So here, I want you to write it down. When angles are given and when the ratios are given. So to find out angle, you need to use a ratio. So when ratios are given, you need inverse, cosine, and sine. And when angle is given, you need to use regular sine and cosine. Okay? Okay, get out your calculator. I want you to hit sine 10. Okay, find the sine button and 10 degree. So make sure you're in degree mode. Okay? So sine 10 is 0.17364. So let's keep 3 decimal places. So 17 rounded up 4. Okay, so sine 10 degree. Sine is so katoa so O over H. So it's basically 0.174 over 1. So this means that the opposite leg of 10 degree is 0.174 times as long as the hypotenuse. So that means, so here, say this is 10 degree and this is right angle, and opposite is, in this case, opposite is here and hypotenuse is here. So this means when hypotenuse is 1, opposite should be 0.174 centimeter. Okay? Calculate and draw a picture to illustrate what each value means. Okay, so sine 20 degree. So we want to know the ratio. The angle is given. We want to know the ratio. So let's find the sine 20 degree. That is 0.342. So that is same as 0.342 over 1. So sine is opposite over hypotenuse. That means sine 20 can make a triangle with 1 centimeter hypotenuse and 0.4342 centimeter opposite. Next, cosine 50. Cosine 50 is 0.6427. So if you round that, 0.643. Over 1, right? Cosine is SOHCAHTOA, adjacent over hypotenuse. Okay, when you have a triangle with 50-degree, adjacent is here. Adjacent is 0.643 centimeter and hypotenuse is 1 centimeter. Okay, so this is one of the triangle that can form 50-degree and that can have cosine 50, the ratio of cosine 50, 0.643. Right? Okay, let's move on. In triangle DEF, identify the side opposite angle D. Here's the angle D. And the side adjacent to angle D. Okay, opposite angle, opposite side, facing 5 centimeters. So this is the opposite. And adjacent. So this is adjacent side. And we know this is hypotenuse because this is the longest side, right? Okay, so identify the side. We did it. And determine sine D, cosine D. So sine D. So opposite over, so katoa, opposite over hypotenuse. And the opposite is 5 centimeter. And hypotenuse, we can just omit centimeter. Hypotenuse is 13 centimeter. So the answer is 5 over 13. So sine D ratio is 5 over 13. And we're going to find cosine D. Cosine D ratio. So ka. Adjacent over hypotenuse. Adjacent is 12 centimeter. And hypotenuse is 13 centimeter. So we can omit centimeter. So that is 12 over 13. That's the cosine ratio. Alright, let's move on. Determine the measure of G, angle G. We want to find the angle measure of G and H, nearest 10th of degree. So when you need to find degree, when you need to find angles, use inverse sine and cosine. Remember, when you need to find the angle measure, you use inverse. Okay? So let's find G first. First thing first, you have to label each side. So this is opposite. And this is adjacent. And this is hypotenuse. And everyone, opposite side is not given. We don't know the lengths here. So we're not going to use opposite. We're only going to use AH, adjacent and hypotenuse. Then what ratio should we use? So when you have so, ka, toa, which one? Use A and H. Ka is using A and H, right? So we're going to use cosine. So cosine G equals adjacent 6 centimeter over hypotenuse, 6 over 14. Reduce it. 6 over 14 is 3 over 7. So cosine G is 3 over 7. And we want to find this G, angle measure G. So what we're going to do is use inverse cosine and the ratio, and that will give you the angle measure of G. Okay, so second, inverse cosine, 3 divided by 7, and that is 64.62. Nearest tenth of degree, so that will be 64.6. Alright, and we're going to find H. So we just found the G, and now we're going to find H. H. This is opposite. We have the label first. And this is hypotenuse. And adjacent is not given, so we're not going to use adjacent. OH. That is here. We're going to use so, sine. sine h is opposite over hypotenuse, which is 6 over 14, and that is 3 over 7. Okay, so we're going to use sine, inverse sine, because we want to know the angle measure. So inverse sine of 3 over 7. Inverse sine of 3 over 7 here. And that will be 25.37. You round it 25.4. So H is 25.4. So therefore, angle G is 64.6 degree and angle H is 25.4 degree. Alright, so do you guys notice something? So we found that cosine G and sine H, they have the same ratio, which is 3 over 7. Okay, so using inverse cosine, you will be able to find G, and using inverse sine, you will be able to find the angle measure H. So this is how you use inverse sine and cosine. Okay, let's move on to example 4. So we want to find AB when 30 centimeter is given and 15 degrees is given. Alright? So always everyone, when you start the problem, you guys have to name each side. So AB is hypotenuse. And we want to find this. We're going to let this be x. Okay? And AC is attaching to 15 degree. This is adjacent. And CA is opposite. So look at this, everyone. Adjacent is given and we want to find hypotenuse. Then when you write SOHCAHTOA, you have to look at adjacent and hypotenuse, AH. Okay, we're going to use cosine. So cosine 15 degree is adjacent over hypotenuse. Adjacent is 30 centimeter and hypotenuse is x. Okay, cosine 15 equals 30 over x. Then everyone, we learned this. So when you have x is in the bottom, when you have x in the bottom, so we're going to switch this and this. Alright? So let's switch it. Then x is 30 over cosine 15 degree. Alright? 30 over cosine 15 degree. And you get 31.05. So nearest, here it says nearest tenth of a centimeter. So we're going to keep one decimal, so 31.1. So it's about 31.1 centimeter. So this is how you find one of the side. Okay, same thing for AB. I want you to pause the video and I want you to try this question by yourself. Alright, look at this. First thing first, we're going to label it. This is opposite, and we're going to let this be x. And this is hypotenuse. And we don't know about this side. This is adjacent, but we're not going to use adjacent. So we are only using opposite and hypotenuse. OA. That is so. SOHCAHTOA, so. So sine 50 is opposite over hypotenuse. Okay, this time x is in the top. Then what we do is multiply 5.2. Multiply 5.2. X equals 5.2 times sine 50. So So here. So 5.2 times sine 50. And that is 3.98. So if you round it to one decimal, it becomes 4.0. So x is 4.0 centimeter. Therefore, AB here, AB is 31.1 centimeter, and this AB is 4.0 centimeter. So this is the answer. And let's move on to the next question. A 5-meter ladder leans against the wall. The angle formed is 62 degrees. Again, everyone, we're going to label opposite, adjacent, hypotenuse. And we want to know how far is the base of the wall. So here, adjacent, we want to know adjacent. So we're going to let this be x. Okay, so AH, we're using adjacent and hypotenuse. AH, that is, so ka toa, ka. Cosine 62 degrees is adjacent over hypotenuse. Multiply 5 on both sides. Then x equals 5 times cosine 62. Five times cosine 62. And that is 2.347. So let's keep one decimal, and that is 2.3. Let's keep two decimals just in case. So 2.35 meters. How far up the wall does the ladder reach? Erase this, and we're going to find opposite. We're going to use the opposite. So OH, let the opposite be Y. Okay? Then OH is, so we're using sine 62 degrees. Sine opposite over hypotenuse. So we have hypotenuse, we know hypotenuse, we're going to find the opposite. So now y is in the top, we're going to multiply 5 on both sides. Then y equals 5 times sine 62 degrees. So 5 times sine 62 degrees. And that is 4.41. Okay, therefore, from here to here is 2.35 meter, and here y is 4.41 meter. So this is how you find the lengths using sine and cosine. Alright, that's it for this section. So I want you to go back to your chapter outline and start doing your homework. Thank you.